Hello everyone, it's Wilson here. Let's talk about integration by parts. This time we get a product of two trig functions. One of them is sine 3x and the other one is cosine 4x. If they have the same argument, then the problem would actually be a lot easier. We probably don't even need the integration by parts, but because they have different functions inside those two trig functions, then we are treating them as two different types of functions so that we got to do integration by parts. Because this is a product, so we are going to choose our u and then also choose our dv so that we actually can set up the table. So first, we're going to set up the table this way with 4 columns with this alternating sign column, and then this one is the differentiation column, that one is the integration column, this is the note column that's being used to keep track of when we can stop. Okay, so now what we're going to do is that we are going to put the plus sign right here, right? And then we got to choose the u, right? We got to choose the u for this one because they're both trig functions, so it doesn't really matter. So we are just going to let u be the first function that you see right here, the sine of 3x, right? So let's do that. The sine of 3x, and then the other function is the cosine 4x dx, but I'm omitting the dx, so I'm just going to put cosine of 4x. Okay, so if you put everything together, then you can see that that's actually just the original. That's just the original integral. Okay. So now, next step is that we are going to be going down the columns. And for this one, we need to do it twice. If you have watched my other video when there was a product of an exponential function and a trig function, then you can see that we got to do it twice because we are also going to go in a loop, right? So now, what are we going to do here? We are going to differentiate, right? So we differentiate, then we are going to be getting 3 cosine of 3x, and then we are going to integrate, which would be 1/4, and then sine of 4x. Okay, and so now let's just write it down here. We are going to be getting negative, and then the integral of 3/4, and then cosine of 3x, and then sine of 4x dx. Okay, so keep going down with the column here. Then now we get a plus sign here, and then we differentiate, right? When we differentiate, we are going to be getting a negative 9 sine of 3x. And then going down this column here, we are going to be getting negative 1/16, and then cosine of 4x here. Okay, so now if we put all this together, we are going to be getting, if we multiply all this together, positive 1 times negative 9 times negative 1/16, we are going to be getting a positive integral here, which is integral of 9/16, right? And then sine of 3x, cosine of 4x, and then dx. And then, of course, we can actually take the 9/16 outside the integral, which now the integral looks like this. 9/16 times the integral of sine of 3x, and then cosine of 4x, and then dx. Okay, so now once you get to the point where this integral that we are getting here looks exactly like the original integral, then we can stop. So what are we doing? First, we are going to set this integral to be equal to w of x, right? So we just give it a name. You don't even need to do this step. This step is optional here. You can actually just write this integral out. But to avoid writing this over and over, it's actually easier to simply just use w. Okay, so we have w, right? That's equal to what? Now let's start writing down our terms, right? Our answer. So it's going to be, we actually need to put the stuff this way. So it's this plus sign right here, right? Which we assume to be positive 1, and then times this u right here, and then times the dv. So we got to You're going to draw the arrows like this. Same thing here for the second row, and then this entry in the third row. Okay, so now multiply them all together, then that's our first term. So that would be positive 1 times sine of 3x times positive 1/4 times sine of 4x, which will give us 1/4, and then sine of 3x, and then sine of 4x. Okay, so far so good. And then next one, let's check the sign first. We have negative times positive times this coefficient is negative, so we are going to still be getting a positive coefficient, right? So we have positive, and then it would be 3 over 16, okay? And then we have the cosine of 3x, and then the cosine of 4x. And then lastly, we are going to be putting in this last term right here. But so you know that this is actually the original integral. So we can call it W. So we are really just getting plus 9 over 16 and then W. It's really because this is W, right? That's the same integral. Okay, so now what are we doing here? We are really just finding W. So all we need to do is to move this term to the left side of the equation. So we are going to be doing what? We are going to be subtracting 9 over 16W, right? 9, 16W. So we are getting 7 over 16W. And that's equal to 1 over 4 sine of 3x sine of 4x plus 3 over 16, and then cosine of 3x cosine of 4x, and then plus the constant integration here, C1, right? And then remember, we are trying to find this integral. So all we need to do is to solve for W, which is done by multiplying by the reciprocal of the 7 over 16, which is 16 over 7. So we are getting 1 over 4 sine of 3x. Right, so we are getting all the stuff, and then remember each term must be multiplied by the 16 over 7, and then plus 3 over 16. Continue, then times 16 over 7, and then also C1 times the 16 over 7, right? We can just call C, and it's really just what? That is really just 16 over 7 times the C1, right? Okay, so now let's clean up the answer. We are going to just start crossing out some stuff right here. The 4 and then the 16 got canceled, and that becomes a 4 here. And then the 16 and the 16 will get canceled. So our final answer will be W is equal to 4 over 7 sine of 3x sine of 4x plus 3 over 7 cosine of 3x cosine of 4x, and then plus the C. And that's our final answer. Okay, so this is actually similar to the other problem that we need to do integration by parts twice, and we are going in a loop, and eventually we're going to solve for that original integral to find the answer. Okay, so that's it for this problem. If you like this video, please give me a like, subscribe my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this video. I will